so it's a relatively faster day. I assume everybody still has some work to do that they're working on to get turned in. So I want to start off talking about power venting. Now, I've talked a little bit about power venting before, but it needs to be talked about again because a lot of new construction has power venting in it. Okay, power venting is basically when you don't have a chimney or when you don't have a good enough chimney to work through to get proper ventilation and to get rid of the products of combustion and maintain draft. Okay, so traditional construction places the vent usually through the chimney inside the structure and exits through to the roof. This is traditional construction. Okay, however, when a chimney falls into disrepair, it becomes a major issue to replace. Both of these chimneys in these pictures are no longer usable. They're so far out of repair, you can't replace them anymore. Okay, this is where power venting comes into spot. Okay, now, interior walls have to be open to access the full length of the chimney. Opening all of these interior walls, pulling out the straps, the joists, and everything like that make replacing a disrepaired chimney a really big deal. A chimney replacement can cost anywhere between $15,000 and $20,000. This is not an easy job. First, you have the removal, and then you have the installation of the new chimney. Now, the industry itself came up with a solution. It's not the best solution in the world, okay? Power venters are awful once you start working in them, but they serve the purpose of replacing a chimney. What it basically is, you're looking at the cross-section here of a house. Okay, so you're in someone's basement here. Okay, the furnace and everything, let me get the pen wherever that went. Okay, the furnace is over here. Coming out of the furnace, we have our vent pipe, the exhaust pipe. It goes into a motorized power venter that pushes the air. It sucks from the furnace side and it pushes the air out a vent on the side of the house. Okay, that's a power venter. This power venter comes on as the first part of the ignition sequence. In other words, we can't even start the burner motor. We can't open an oil valve. We cannot start anything until this power venter is running. This is called sidewall venting, is another word for this. We don't anymore have to worry about repairing the chimney. Okay, it eliminates all the chaseways and everything through there and gives much more living space because I don't have that chimney going up through the center of the house. Okay, so again, we have our boiler or furnace down here in the basement. We have our vent pipe connected to a power venter. And we have the exhaust that goes outside the house. Now, there can be no windows around here. There's very strict guidelines on where this can be installed. All gases and soot are propelled by a jet action from the exhaust, which prevents staining of the building exterior. Okay, you should never see soot buildups anywhere around here. If there's soot buildups anywhere around there, the power venter is not working properly. Okay, when you look at the inside of a power venter, it's basically just like this. We have our boiler here. Okay, we have our vent pipe connected to the boiler. What's this right here that I circled? What's this that I'm putting an arrow on? Anybody? What's that?
Not sure.
That is a vent as well, isn't it?
We talked about it a little bit yesterday. That's the barometric draft damper. Okay, that's the one with the little swinging door and the weight that I said you have to adjust if the draft is too high or too low. Okay, so just because there's a power venter on here doesn't mean we still don't have to adjust draft. Okay, what this does, if the draft is too high in the boiler or furnace, this allows air to come in, and air mixes in here and reduces the draft over the furnace. So again, if there's too much draft, we let basement air mix in here, and it reduces the draft. Operation of the power venters, we use them on both gas and oil equipment. Okay, they're quiet. Most of these are mounted on shocks, little springs, little pieces of rubber to prevent vibration transferring to the floor joists. They're energy efficient. We have much more control over the draft, and a damper closes and blocks heat loss during the off cycle. They are safe. They interlock with the burner to monitor vent systems. Okay, a pressure switch monitors and detects outlet blockages. In other words, if the snow gets too high on the outside of the building, the thing is going to shut down and shut the furnace down. A high limit switch interrupts the burner if this gets too hot. Okay, so there's a lot of safeties in this thing to prevent overheating, no output, and the motor not running. Okay, a lot of safeties in here, but this all becomes part of your ignition sequence. Thermostat calls for heat. The power venter has to start first. The power venter has to be proven that it has started before we can start the furnace or the burner. Okay, first step of the process. Power venter doesn't start, nothing's going to run. Okay, now, you're seeing more and more of these over time. Okay, a lot of new construction is using power venters. Why?
Easier installation and efficiency?
The building contractor doesn't care about installation or efficiency. What do they care about?
Cost. Money.
Money. So very expensive, to the tune of $20,000 to build a chimney. If I put a $4,000 or even a $2,000 power venter in, I've saved $18,000. Okay, they're not going to reduce the price of the house that much, but they've made that much more profit. Now, from a service technician standpoint, okay, these things are awful. Okay, the oil exhaust is very acidic. Okay, it contains a lot of acid, especially if it gets damp. It's very acidic. So the problem that occurs in a power venter is that little blower wheel that I've just circled. There's a little squirrel cage in here. This will start breaking down. It will start rusting and corroding. Okay, as that breaks down, there's a lot less suction that happens here.
What's it?
Cover me up.
Get her the fuck off the bed, man.
Okay, I'll mute the person. There's a conversation going on there. Okay, so the exhaust comes in, gets picked up by this vent, okay, and blows out here. There's fresh air that's taken in from the outside to mix with that exhaust air to give us the volume to blow it away from the house. But this wheel that's in the center there corrodes. This motor shaft corrodes. Okay, there's a pressure sensor right on the outside of here. That is what senses whether or not we're moving air. That corrodes. So power venters are very subject to metal corrosion. Okay, where your furnace or boiler may last 10 to 15 years or 20 years, this power venter has an average lifespan of about 5 to 6 years before it has to be replaced. Okay, it's not a long-lasting piece of appliance. Any questions on the power venter? Any questions about where it would be used? Okay, so if you replace this part, while you're at it, you may end up replacing the motor because the shaft is so damaged you might not get a new squirrel cage on it. Okay? So parts are replaceable, but sooner or later the entire metal housing is going to start wearing down. And at that point, you just can't replace pieces of metal housing. It's done.
All right.
Any other questions on power venters? So if I came along and asked everybody the sequence of operation for an oil burner with a power venter, everyone would be able to tell me what it is?
Not immediately.
Okay. Sequence of operation of an oil furnace with a power venter. Thermostat calls for heat. Power venter starts. Power venter proves draft by the pressure switch closing. That energizes the primary control, which energizes the burner. The power venter runs the entire time the call for heat is going on. Entire time the call for heat is happening. The power venter continues to run. Thermostat satisfies, signals the power venter to shut off. Power venter does basically a post purge cycle. Power venter continues to run after the burner shuts off to get all the products of combustion out of the house. Once that post purge cycle is done, the power venter shuts down. All it is the power venter is the first part of the sequence of operations. Questions on that?
No, sir.
Okay, it's actually a pretty clear sort of thing. There's nothing new there's really nothing that special about them, but they are a pain because of that interlock. Okay, and an instructor way back when, the guy who taught me oil, told me power venters suck in more ways than one, and they do. They're not nice to work on. Burner operation, normal sequence of operation. Thermostat calls for heat and activates the furnace through the safety control. The burner runs until a sufficient amount of heat is built up to activate the fan control and start the blower. That's usually about 140 degrees. The burner and the blower run together until the thermostat is satisfied. The burner then shuts down. The blower continues to run until the heat in the furnace has been dissipated and the fan control shuts off, usually between 100 and 110 degrees. Something seen quite regularly is the furnace shutting down on high limit during the normal cause of operation. In other words, you're going to be in the basement. You're going to see the furnace run quite normally. The fan continues to run, but the burner shuts off. The fan continues to run. Then the burner comes back on after a few minutes, shuts off again, and it cycles. You have to check if the controls are set properly. Is the blower actually operating? Is the fan belt broken or slipping? There's two other things to check. If your furnace is going off on high limit, what are the two other things that are important to check? Anybody? What two things do you check if a furnace is going off on high limit?
Squirrel cage.
Actually, squirrel cage would make three. We have two other things that we need to check. They're relatively obvious.
CAD cell?
No, because then the burner wouldn't run at all on CAD cell. Burner runs, burner shuts off on high limit, fan continues to run.
Electrodes.
Burner would be shutting off on safety. Well, think about the air side. Am I moving air through a heat exchanger that's absorbing the heat?
Sure.
Well, I would hope so, since I'm putting heat into the house. So I have air being pulled through the blower motor. That air is going across the heat exchanger, absorbing heat from the combustion side of it, and blowing out the registers into the house. Okay, that's what keeps the heat exchanger cool and under the high limit. What happens if the filter's dirty?
Needs to be replaced or cleaned.
Yeah, but will my furnace overheat?
Oh, yeah.
Okay, so if you have a furnace that's bouncing off on the high limit, okay, one of the things to check is make sure the filter's not dirty. What's one other thing you need to check if a furnace is bouncing on high limit, coming on and off based on high limit control? And I'm saying furnace, forced air. I feel there's a quiz that's going to be coming on shortly. Okay, one of the other things you need to check is whether or not people have closed registers in rooms. I have to maintain airflow. Happens a lot, especially in more of the elderly. Their kids have all moved out. They've changed the rooms over from a bedroom to a lounge or a sewing room to make sure their kids don't come back home, a feeling I can well understand. And so that they in the winter months, they try to save money and close off the registers in those rooms. Well, I suddenly don't have a lot of airflow. Okay, we got to make sure the registers are open. Okay? So that's what happens on high limit. What about low limit? What could cause us to shut the fan off before the call for heat is over? In other words, it cuts off on fan cutout. What can we have go on? Low limit operation.
Bad draft?
I want you to think, I want you to think more about nozzle sizes. Low limit operation. I'm not producing enough heat to keep the fan running. Okay, so in other words, the furnace is cooling off too much. Nozzle's undersized. Okay, is what it boils down to. Nozzle's undersized. Not enough oil to keep the heat going, to keep the fan going. Okay? Too much airflow, stuff like that. Okay, nozzle undersized. Now, let me pull up, let's go ahead into our simulator. Okay. Oil heat simulator, Simu Oil. It's on the simulator system. You go into it, you come up with a main menu. Once you have the main menu, we need you to log in. Okay. We have you log in, if I can remember what I used as a password. There we go. Okay, the first time you go to log in, okay, you have to create a new user for yourself. It's interesting that we only have a couple users in here. Okay, first time you go to log in, you have to create a new user. It's going to ask you first name, last name, password. You're going to have to enter it twice. Okay, so once you log in, then you can start taking a look at the system. Okay, you're going to run it normally at first. Okay, so from the main menu, you're going to press a run normal. Okay, you're going to turn the power on. Oil valve is open. We'll turn the stat set point way up. Okay, we'll turn the thermostat set point up. System comes on. We have flame. That's our normal operating procedure. We have a draft gauge. We can put the draft gauge into the flue pipe. I have a negative 0.05 draft. That's within our safety ranges. Okay, I have a combustion analyzer. I can get things like stack temp. Okay, I can get things like net stack temp. Everything that I did as a part of the preventative we talked about the other day. I can take a smoke test. Okay, and I can actually see what my smoke color is if you look closely at the screen. The dot says what it was. Normal operation. Okay, I could put an oil valve on. I could put a gauge on the nozzle and inlet ports. Okay, so if I wanted to put an oil gauge on here, I can see what my oil pressures are. My pressure is 100 psi. My vacuum is basically 0 inches. Okay, blower motor hasn't come on yet because I'd see that run. My air filter is right there. I can glance at the air filter. So if I click the view, I can view the air filter. Air filter's clean. I also have the ability to view a few other things. I can view anything that's in this list. I can view flue pipe if I wanted to make sure it's not clogged. Okay, so I can come in there and view anything in that list. I can look at the draft regulator. I can see if it's open or closed. Okay, so there's a lot of things I can view. I can go to now the fan has started blowing. You can actually see the squirrel cage move. So if I wanted to take a temperature, I could take a temperature of my supply. I could take a temperature of my return. And I can see my supply air is 132, 133 degrees. My return is a pleasant 65. So we're heating the air by that much. I can go to my electrical side. And I can use an amp clamp. And I can take the amperage of my blower motor. I can click on the meter. And I can take an amperage of my burner motor. I can also take the amperage at my main disconnect, which is coming in from L1. It's labeled CB. That's a circuit breaker. So I can see the amperage of the entire piece of equipment. If I wanted to, I can come over to the voltmeter. I can take my voltage in a lot of different places. I can take a voltage across FLS. It tells me if the switch is open or closed. Once I have the meter in, I can click on the meter, and I can take a voltage across all of these other locations. Room thermostat. I could take a voltage once my meter's in. I could pick, let's say, taking a voltage across the primary side of my transformer. Okay, again, clicking on the meter. Okay, allows you to reset and take voltages in many different places to help you troubleshoot. Clearing in OK gets rid of the meter. To take an ohm reading, I cannot use the ohm meter with the circuit breaker on. I have to turn power off. Then I can use an ohm meter. Let's say I wanted to ohm out the blower motor. Okay, I can ohm the blower motor. Okay, so I can take a number of ohm readings, and I can always see where my ohm readings are by clicking on the meter and getting the different spots. Okay, and I can get rid of the meters by just clicking clear and OK, and then I can turn my power back on. You cannot have power on using the ohm meter. It's part of basic diagnostic skills. Okay, once I know how everything works, once I've looked at all possible readings using my test tools when the system is running properly, I can come out back to the main menu and I can run a fault, okay, which I still have to program in. Okay, and once the faults are programmed in, which will be done by the end of this day, we can practice troubleshooting on the Simutech simulator. There's a lot of faults we can put in here we cannot replicate in shop because they're dangerous. Okay, when we're using an electronic simulator, I can put some stuff in here that would be too dangerous to do in the shop, but it's stuff you're going to see in the field. For the simulators, there have been directions sent out a number of times on how to deal with the simulators. Okay, I sent directions out in your welcome to the course email. I've put announcements in the courses on a number of times. You guys are going to have to start using the simulators. I'm cutting lecture short today because I want you guys to start using the simulators. Starting later this week, you're going to have labs that are going to specifically say, go use the simulator and fix the faults that are out there. I can see everything that was done in the simulators. If you fix faults without using your test tools, without using diagnostics, I can see that you just fixed it and got the answer from somebody else. Don't do it. Okay, we do look at the repair logs. Okay, simulators are a required portion of this course. Every campus is using them in other courses that are being taught right now. We know they work. Okay, so telling me, oh, it doesn't work for me, whatever, doesn't cut it. Questions on simulators?
I have a problem getting to it.
How do you get to it, did you say?
Yes.
I have directions, and I'll repost them in the course announcements. I actually did a video on it as well. In your introduction announcement, when I first put you guys, when we started the term in your electrical for oil heating, okay, in the announcements and in an email I sent you, okay, down at the bottom, the start of the course, I gave you simulator install instructions. Okay, it gave you the where to go, it gave you the user IDs and the passwords. It even gave you a video on how to get into it and how to set it up. Okay, so again, under announcements for the 214 course, there was a simulator installation instructions. That's where you find it. Okay, so the announcements are out there, the directions are out there. Other than getting, how do I get into it? Is there any other questions?
How did you get that voltmeter and ohmmeter up? Because when I click on it, it just brings up an arrow. It doesn't bring up the actual meter itself like it was on your...
Oh, you have to place that arrow. Let me get back over there.
Because I'm on it now trying to mess with it just to...
Yeah, very good question. You have to play. Let me go back into it, and I'll show you.
All right, because mine just has that arrow, so I was a bit confused.
Okay, so if I go to electrical, okay?
Yeah, that's what I have up.
Click the voltmeter.
Yeah.
Okay, you get an arrow like this.
Yeah.
You actually have to put it into the circuit, so click on something where it lets you click, and then click on something else like neutral, okay?
Yeah.
Once you have those two arrows placed,
okay,
you can click on the meter, and then it will automatically move it around depending on what you set.
Okay, I got you. That makes sense.
Does that make sense now?
Yeah. Yep.
Any other questions? Gentlemen, your project for today is finish up any outstanding assignments you have. And then I want you guys to go in and mess around with the simulators in the non-fault condition. I'm going to put faults in later this week. But until you work with it running properly, it will not work. You must create a user ID when you go into the simulators. Okay, do it now because you won't be able to solve faults without having a user ID. And yes, faults will be a graded activity. Okay, so for those of you who are not on the call today, listening to my recording, or for those of you who know people who are not listening to my recording or lecture, let them know faults are a graded activity. It's required. Okay, that's all I have for today. Told you it was going to be a short day.
Cool. Copy that. See you tomorrow, boss.
Spend the time on simulators, please.
Sir, yes, sir.
Yes, sir.
Cody Reva out.